In the previous video, we understood why the data cleaning or data munging steps were important. Because of this reason, garbage in, garbage out. Now let us understand how good is the data. What is the measure to say how good is this data or how bad is this data? Because we need some measure to understand, to differentiate the quality of a data. So that is what data quality means. So we need to be able to quantify how good the data is. One good way to measure the quality of a data would be to check the data against a predefined set of constraints or criteria. Now, if our data follows some predefined criteria, then we will say our data is clean. So that can be one idea to measure the quality of data. Another idea can be the check should be customized based on business need. Maybe in some scenario, if your data contains outliers, then that might be a problem. But let's say in some scenario, just having the outlier in our data may be good also. So in some scenario, the same data might be bad. In some scenario, same data might be good as well. So that means the data quality should be customized based on business need, what the business requires. Same data set might be good enough to answer a given question, while the same data set might be bad to answer another question. So remember this. So it depends upon a scenario how much cleaning of a data should be done. It is on the based of business need. If your business needs like 50% of data that needs to be cleaned, then you need to customize your cleaning process according to your needs. So for that, we are going to understand about data quality. So typical area of check for the data quality is to check for validity. So this will check, is our data valid or not? Is our data maintaining some level of constraints or not? Let's say for some data, I have the column name is age. So let's just say it is my age column, and I have told my constraints that the person that I will be inserting here should have the age between 10 to 70. Let's say this is my constraints. This is the range that I have defined for this age column. Now I have the data that is 7, let's say 24, let's say 80 and 70. Now this is the data that I have inside the age column. Now I have the first data that is 7. Does 7 comes within this range? No. I have defined from 10 to 70, so clearly we can see this data is not valid because it does not comes under the constraints that I have defined. Similarly, does the value 24 comes within this domain? Yes, it is between 10 to 70, so this is valid data. Does the data 80 comes within this range? No, it is well above 70 values, so this is again invalid. Now the value 70 comes under these constraints, so this is valid data. So in this way, we can have the predefined constraints, and based on these constraints, we can define if our data is either valid or not. And second is accuracy. Accuracy tells us if our data that we have collected is accurate or not. That means, let's say our actual data was this 4, 3, 6 and 1. So this is our actual data. This is a true data. This is what it is in a real world scenario. This is the true data. But while measuring the data, I got something like this. So for the first instance, I got 4. For the second instance, I got 7. And for the third instance, I got 8. And for the last one, I got 1. So this was a true data, and this is what I measured. Maybe I used some instruments, I used some measurement scale, and I measured this. Now you can see for the first data, its true value is 4 and its the predicted value, let's say the measured value that I have measured using some machine learning algorithm. Then I measured the value as 4. Now the actual data is same as measured data. So that means it is a true reflection. Our measured data is a true reflection of the actual data. So you can see this is accurate data. 4 is accurate data. Now our actual data was 3, but our model predicted or our model measured it as 7. Now this is a falsified data. This is not accurate data, but since here you can see the actual was 3, but we have measured it as 7. So this is wrong data. This is not accurate data. So similarly it was 6, but we measured it as 7. This is not accurate. Actually it was 1. We measured it as 1. So this is accurate data. So in this way we can see if our data is accurate or not. Similarly, completeness. So completeness means if we measured all the source of a data, if we cover all the domain of a data for our data to be analyzed, then it is a completeness. Consistency means does our data agree with each other? Let's say I have different columns. Let us say that I'm predicting if the user will buy something or not. Let's say I have this buy information and I have the name, let's say name of a person, address of a person. Now can you see here, does the name attributes have some effect on whether the person will buy anything or not? Can you tell us, having the different name, can a customer buy something or not just based on this name attribute? No, because it does not depend upon a name. So name can be anything. We cannot make our model using this name attribute. So this is not a consistent data, because using the name we cannot predict whether the customer will buy something or not. Maybe we need something like the person history, historical information. Let's say if the person has bought something from our market or not previously, that information might be relevant, but the information of the customer name is not important to predict whether he will buy something or not. So this is an inconsistent data here. And uniformity. Uniformity will check whether or not our data is uniform. It is under the same scale or not. So for example, I have a data that has been measured as a weight in kilograms, let's say. So I have the weight of a customer, let's say this is the weight of any person, and some of the weights are like, let's say 50 kgs, 60 kgs, so these are on kgs. So this is the unit of a weight. And I have also within this same column, I have another weight which is measured in pound. Let's say it is in pound. Now you can see it is not uniform. Some of the units are in kgs and some are in the pounds. So you can see different in units, and that is what non-uniform data means.